Hey cool kids, my name's Max and you're watching the Science Channel. Today's rad topics are Newton's 3 laws of motion. We'll start with number 1, which states that an object will stay at the speed it is going, including 0, unless it is acted upon by a net force. Okay, here we go. So this is our example of no net force. As you can see, our normal force and our gravitational force are the same, but in opposite directions, so they cancel out. They're 0. So that would mean that there is 0 acceleration. So that means this ball is our example. It's not speeding up, it's not slowing down, its acceleration is 0. On the other hand, we have net force, because the friction force and the applied force are unbalanced. They're different. An example of that would be when I rolled this ball, vroom, 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 it sped up. That's because there was a net force acting upon it. It was accelerating. I'll show you again. It accelerated because it had a net force. Okay, on to Newton's law number 2. This one can pretty much be summed up as F net is equal to m times a. F net stands for net force, m stands for mass, and a stands for acceleration. This is an example of it. We have our F net equals m times a. We know 2 of these. We know our mass is equal to 5 kilograms, and our acceleration is equal to 10 meters per second squared. By knowing these 2 and plugging them into our equation, we can solve for our net force, which turns out to be 50 newtons. Here are some other examples. When we double our mass, our net force was also doubled, from 50 to 100. When we doubled our acceleration, our net force also became doubled, from 50 to 100. If we double both, our net force is doubled twice, so actually quadrupled, to 200. We can also rearrange our equation of net force is equal to mass times acceleration to mass is equal to net force over acceleration, and acceleration is equal to net force over mass. Using this, you can solve for any one of the 3 variables. Newton's 3rd law states that every force has an equal and opposite force. For example, when I lean against this TV, it also pushes it back against me with the same force. Another example is with these 2 balls. When I rolled them against each other, both of them hit each other and exerted the same amount of force, but the volleyball rolled much further because it has less mass, causing it to be affected more.